Okay, so calm down, people. Next session is approaching. So the next session is called AI-assisted security hardening of CAP applications, and our speaker, Markus Braun, will explain you how you can use AI tools to harden the security of your CAP application. So with that said, short introduction, please go ahead.
Thank you, Michael. Yeah, also warm welcome from my side to this session. So my name is Matthias. I'm working as security expert for the CAP team. And in this role, I have to deal a lot with CAP authorizations. And when I learned one thing about authorization, then that is that they are or can be terribly complex. But at the same time, they are crucial for the success for your application. So bulletproof authorization enforcement is absolutely crucial. And with the rise of AI tooling, there's even more pressure on us. It's because there are so many evil people out there making use of AI tooling to attack our APIs. And I think the only good answer we can give to that is equip ourselves with best AI tooling we have, improve our APIs, do the hardening, fight back, and protect our assets. In the last couple of weeks, I experimented a lot with AI tooling, so with coding agents, and I came up with a small demo application. It's an HR system with 4 different services reflecting different user flows for the AR system. So there's a people service just to browse employee data of the company's employees, so with contract details and profiles. So that's more as a read-only service. But there's also an employee service because, of course, every employee of the company needs to update his or her own profile, but maybe also to track more sensitive information like salary adjustments, goals, and performance reviews and the like. And we need people that actually also do the maintenance on that kind of records. Of course, I can't adjust my own salary. That is usually a manager doing that, and this is manager service. So different perspective on the domain. Last but not least, there are maybe administrative users who can set up the overall organization. Let's have a deep dive into the manager service to show how authorization actually work. So we have a manager service to expose employees as a central entity with the profile of an employee. And also as a composition, we have the sensitive information as a read-only, in a read-only deep mode. So salary adjustments, reviews, goals. Now, of course, not all people should be allowed to access managed service. It's bound to authenticated user. So it's not in any way an explicit role, but rather open for all authenticated employees. But of course, we need to restrict somehow the access to the employee records. How do we do that? We want only managers to be able to touch employees' data. So adding salary adjustments by action add salary adjustment, and also get basic data profile data. How is it restricted? So we have a restrict authorization here. So we just say, hey, we filter for all employees which are assigned as manager of a department of which the employees team is part of. So with a hierarchy, so there are departments. Below the departments, we have teams, and each team has assigned employees. And this is the reporting line of a department, and the manager of that department should be able to do the salary adjustment. So this is a typical scenario for instance-based authorizations. Now you also already might see or come up with some questions. So of course we have to restrict grant on the employees, but could it be maybe possible to move an employee from a foreign team, not in the reporting line, in my own reporting line by any request via the protocol? Or is there maybe some direct access to salary adjustments, which is an auto exposure to my service? Is that sure that there's no direct way to manipulate that data? so not being a manager of the department. So overall, we see that there are so many different techniques to model authorization. So we have annotations, we have projections, we have compositions, and all of that together form an effective API, which is the playground in the end for the attackers. And it's exposed by the model we defined in our project. And the question is how to ensure that the effective API actually fully matches the intended access rules. And this is a very, very hard question to be answered. Now let's go to the demo how AI can help with that. So I have my sample application here, so capital people, and I added 3 different skills. So skills are kind of instruction set to give coding agents more context about a specific task. And I started with CAP roles inspect as a skill, which means that the coding agent, so I took Claude Code here, but it could be done with any other coding agent as well. And by the way, also runtime agnostic, so that holds for Node, for Java, whatever. So the skill is agnostic. And in the skill, I just tell the agent which sources should be collected to extract the authorization model. Yeah, so there are model files. We have, of course, handler files, because you might have handler code that do authorization enforcements, configurations, and so on. In the second step, there are some instructions how to extract then the authorization model. And in the first step, how to produce a meaningful report out of that. The goal is that we have a better understanding and overview about what actually we modeled in our application. And the result shows up in the report, so we can't do that online here because it will take 2 or 3 minutes. But I already prepared that for you. So there's an inspect HTML file, and it starts with the CAP roles inventory. So this is now all AI generated. It shows me all used roles that has been detected. So there's an HR admin. That's an explicit CAP role, which you find in the HR admin service. And there's also a semantic description what this use is actually about. So this is a really semantic description. It also finds any pseudo roles. So we already have seen the authenticated user in the manager service. And it also knows about the context, how it's used there. So in the manager service, we saw it's about the hierarchy. And it's not the case that any authenticated user can access the employee data. It's rather along the reporting line. And now that the AI actually found the manager persona is really a cool thing. So it actually detected that even though the manager is not an explicit CAP role, it found that this kind of a data-driven role that should be regarded in testing, because it's a difference if you are a manager of a department or not. And we need to come up with test data for both cases. And the AI actually found it, which is pretty cool. AI also prepares an access matrix. So let's have a look into the manager service. We see all the resources that are exposed. So the directly exposed ones, so employees, departments, and teams, so which we saw in the diagram, but also the auto-exposed entities, which are implicitly exposed by the service. You also see which events are possible for the different personas. So most notably, it's the manager persona, which we saw. Any other authenticated user does not have any access. But even the manager has some only scoped access, and it tells us, so scope means actually semantically employees and teams belonging to department the user manages. So this is derived by AI. So I did not add it. This is found by the AI in the model. And this access matrix gives a nice overview what is actually possible with different roles in different contexts. Last but not least, there are also some recommendations. So it actually found some shortcomings in my model. In manager service, for example, I used a filter condition with a string literal. And it tells me, hey, better use a CDS expression. This is compile safe. So it is kind of a linting mechanism out of the box. I actually did not told him to do that, but it did. Also pretty nice, in the people service, it found that employee's birth date is in the part of the public protection, can be accessed by any employee in the company, which might be a GDPR issue. Just a recommendation. Well, then, as a second skill, I added CDS roles data, and this one now is about generating test data required to do comprehensive testing. So it takes the analysis as an input and then creates test data required to test any kind of combinations from requests, so combining the different users, the resources, the events, different protocol adapters even. And creating all the required records to do a deep testing. It's added in this test folder. In the same way, it also adds a profile in the CAP roles data, which comes as an overlay to the existing one, meant to be executed locally. So adding the test data, adding also all the mock users required for testing. So that's now the CAP roles inventory reflection, right? It adds a test manager without any roles, but the test data is already there to test this manager. So there's a reporting line to be tested. So that's now we have the data, we have the analysis. Now let's go the third step with CAP roles verify. And that is now the crucial thing. So now we want to generate all possible combinations of requests against our service. And the verify now comes up with unit tests, adding to a test folder. Now this is a Java project. For Node, this would be Node tests. In Java, it's a mock MVC. Can be directly run in the editor. And it's now a very, very long list of any kinds of requests you could imagine, structured along the service, going down to the resources, so the employees here, and then testing all kinds of users that are possible. So just for an example, in this test here, of course, a request to an own data in the employee service, querying the own user should be possible, is okay. But of course, the returned, so the response should reflect the own user. This is assured here. Also, if I get the full collection, so on the employees, I just get one record and it's me, it's the own user. Then, of course, there are a lot of deny tests. So there's, if I request a different user, I get a not found. So this is the expectation. So the AI generates the unit test along the expectations. Of course, there are even more complex tests. You know the OData protocol. You can use expands to navigate down. You can use filters to find about values in the model, and that is all tested in this generated unit tests. Hundreds of tests, and in the same way, you also will find in the HTTP folder, one by one for each unit test, also an HTTP test request, which you can use to reproduce each single unit test. If you start up your local service as shown here, yes, you could easily copy that line, start a server, and just execute all that tests. Now the verify also shows us a report. This is the last thing I want to show you. So the question is, do all unit tests do the right thing? Is everything green? No, actually the report says, hey, there's one critical issue, and we can have a look into. It says, hey, we have an issue with manager service, employees, entities affected, action add salary adjustment. Oh, not good. The model says actually only a manager within the department chain should be able to perform that. AI states, hey, this is actually not fully true. in case an employee belongs to a team which is not yet assigned to a department, so with a null reference, then actually a manager can run this action, doing salary adjustments. Oh, I was kind of shocked, and it actually can prove that in a unit test. It's there, so it's one of the tests. I could also show you that it's actually breaking. So it's in the manager service, so we can run. So now goes through the test. So this is really fast because everything is local, right? So now there will be a lot of green tests, of course, but should also show now a failing test, right? This is the test failing, and it shows, hey, a manager can run this action, add goal, for a specific employee, which has been created in the test skill, right? With an orphaned department. Hey, this is breaking and needs to be fixed. Of course, you could now use AI to fix that, make your test green, and then have a regression test for the future. Back to the report. It even gives you some additional information. Well, also the exploit on the CLI level. Also, that is there. You can run your service in this test profile. You can send a curl request, and you will see the exploit. And then you can also debug and fix. And there's also root cause analysis, which is pretty complex here. So actually, it's about multi-hop association path, which in the end translates to left outer joins in the database. And the recommendation is to go with exist clauses. And there's also a link to the authorization guide. Actually, this is a recommendation to go with that, and it would prevent actually this exploit. Yeah, so far about the application I tested. I had some learning. So AI can definitely help to analyze your projects, even to ensure consistency, and even on a semantic level. Even that is possible. And it significantly improves test coverage of authorizations. I think that is key for hardening, because the playground, so the area of possible requests that your model exposes is huge, and it's nearly impossible to do that manually. So it's really helpful to have AI help to make sure that the playground is guarded. But yeah, last but not least, never rely 100% on AI. So AI is not perfect. I also found that it will never detect everything. You should stay always in control, always understand your authorization model and what's going on. There's no way around, because AI will not be perfect. Okay, and with that, I would close this session. Thank you very much for your attendance. Thank you. If you want, we can give us feedback. Otherwise, I wish you a nice recap.
Okay, thanks, Matthias. Do we have any questions in the room? Okay. Mark, sure.
Are you sharing these skills that you have shown?
I'm planning to do so. There will be hopefully or eventually a skill library provided by CAP, but before that, I need to productize, making sure that it also works in any kind of other projects. I did not so far, but as this is already a pretty complex example, I guess that in other projects it will work as well. But it will take some time to productize and to make it working on a generic level, which is, by the way, not that easy for skills. So it should work for Java, for Node, and they behave similar, but not always very same. And even though I'm running with CAP MCP, which is a precondition, that alone is not enough to give that precision. So the skill is very important here.
Gesundheit. Do we have another question?
And do you notice any differences depending on which LLM you use in the background that uses the skill?
Yeah, that's an interesting question. So I think I started with Opus, which is known to be stronger than Sonnet. I switched back and forth. So maybe for the skill development, Opus was better, but I guess that Sonnet would be okay for the skill itself. But that's also something I need to figure out. And I also would like to try with other coding agents how they would behave. That it's a different kind of engineering, right? It's more about trying out. Yeah.
So, looking at the time, one last question would be possible, I think, if we have one. Don't be shy. Okay, no, nothing. Then we are finished. But Matthias will be around for a while. So if you suddenly have a question and see him, just feel free to ask him.
Okay, thank you.
Excellent section.
Hey.
I'm from SAP. I have a question. Is it in the internal skills library? Or not yet?
It's not yet part of that, but I am planning to add it to the CAP skills library as soon as possible.
Alles gut, keine Panik. Alles gut.